Hey everybody, so here we are. I would rather be at Luna teaching you guys, but this is our next best option. So today we're going to be talking about polarity. So we're going to get started now. So our objectives for today, by the end of class, you'll be able to determine the solubility of a material based on its polarity, and you'll be able to identify solutions containing electrolytes or non-electrolytes. You are welcome to follow along. I've posted the guided notes as well. If you want to print those out, you can be filling out as we go through. If not, you can take notes on a separate sheet of paper. It's up to you what you'd like to do. So we're going to get started just by defining a few terms that you should know. So a solute, this is a substance that is being dissolved. So if we think about this image here, this would be our solute, okay? So think about it as like, if you were going to put salt in water, right, your solute would be the salt. And then we have our solvent. This is the liquid part. This is what your solute is actually being dissolved in. So here, our solvent would be water, okay? We are putting this crystallized substance into water, which is our solvent. And then the solution is going to be the final product of your solute being dissolved in the solvent. So let's think about if we were to get some lemonade mix or some Kool-Aid mix, and you're going to make lemonade. In that case, your solute would be your lemonade mix, right? You're putting that into your solvent, which is water, and then you are creating your solution, which is lemonade. So one of the major things in this unit is this idea of solubility. So solubility is the likeliness of a solid, liquid, or gas solute to dissolve into another solid, liquid, or gas solvent. So essentially what that means is it's the ability of a material to dissolve into another material, right? Will our solute dissolve into that specific solvent? And so we could say something is highly soluble if it's very likely to dissolve in another material, and we would call it insoluble if it's very unlikely that it will dissolve in that material. A lot of the time, we're going to be talking about aqueous solutions, and basically what that means is we are dissolving other substances into water, so water is acting as our solvent, and that'll be true for a lot of the different things that we do in this unit of solutions. So we are going to see an example I did with mixing oil and water to see, is it highly soluble, is it not soluble? So we are going to watch this video. Hey everybody, so we're going to do a quick demo. We're going to be mixing oil and water. So I have my water here in the beaker, and then I'm going to add 25 milliliters of oil, and we're going to see if it's soluble or not, okay? So here I have my beaker. I am adding my oil, and we should see that bubbles are forming on the top. I'm going to stir it, and let's see what happens, okay? So we're stirring it up, and you should be able to see that we have two distinct layers that have formed, right? So we have this layer of water, and then on top we have this layer of oil. So this is not going to be soluble, and we're going to talk about why. Okay, so returning to our PowerPoint. So as we saw in the video, the oil did not dissolve into our water. So was our first material soluble in the second one? No, it was not. So we could say that was insoluble. So I would like you guys to try now. So you go to your kitchen and if possible, get a clear cup. If you're not able to get a clear cup, then just any cup will do, and put some water in the cup. So maybe I would say fill it up about like 3/4 of the way, And then you can pour around 1 tablespoon of sugar into the cup and stir. And I want you to come back and tell me whether the sugar was soluble in water or not. So you get 5 minutes to do that. I'm going to start the timer, and I want you guys to go to your kitchen and try it out. Okay, our timer is up. So hopefully you had time to go and do that. If not, pause the recording and go and take all the time you need. But you should have seen that sugar did dissolve in water, so it was soluble. And now we're going to talk about why are some things soluble in water and why are some things not. So our key concept for this unit, when we're talking about solubility, is this idea of like dissolves like. So substances with the same polarity are going to dissolve in one another. So thinking about our oil and water example that I did, the reason that they did not mix together, right, the reason that the oil was not dissolved is because oil is nonpolar and water is polar. So polar substances, they will dissolve polar molecules. Non-polar substances will dissolve non-polar molecules, but a polar substance will not dissolve a non-polar substance and vice versa. So we have some key conceptual things that I want to discuss. We talked about polar and nonpolar a little bit in quarter 2 during our chemical bonding unit. So we're going to revisit this idea. So talking about polar, when you think about a polar substance, you want to remember polar is soluble in a polar solvent. So a polar solute will be soluble in a polar solvent. So a polar covalent bond is the type of chemical bond where a pair of electrons is being shared unequally between two atoms. So it's a covalent bond we're still sharing, but you're going to have one atom that wants those electrons more than another. So our example in this case is water. So thinking about water, we remember that oxygen is a member of group 16. So it has 6 valence electrons, and it really wants to gain those last 2 so that it can have a full octet. Remember, we always talked about this idea of balance, and when something has 8 valence electrons, it's balanced. So oxygen really wants to gain more electrons, and because of this, it has a high electronegativity. Whereas hydrogen, it only has 1 valence electron. It's not really looking to gain more. So as you can see, we have these little negative and positive signs here. And what that means is this is showing a dipole moment. So basically, you have a polar molecule here. That's what it's showing you, right? So because oxygen really wants those electrons, it's pulling it closer towards it. So that's why the oxygen has the negative symbol there. So anytime you see any sort of dipole moment symbol, that's one indicator that you're dealing with a polar molecule. And then if we're thinking about nonpolar, so nonpolar solutes will be soluble in nonpolar solvents. So thinking about nonpolar covalent bonds, this is a type of chemical bond where 2 atoms are sharing a pair of electrons with each other. So we are sharing equally in this case. You don't have one atom that wants those electrons more than the other. So our example here is carbon tetrahydride, otherwise known as methane. And so carbon is not a highly electronegative element, and neither is hydrogen. And we also can see, looking at our geometry, if we think back to the Lewis structures, this is a tetrahedral structure. So we have one central atom with no lone pairs that has 4 atoms bonded to it. It's very symmetrical, which is also an indicator that it is a nonpolar substance. So there's a trick that you can use to remember to try to figure out if something is polar or nonpolar. So you want to be thinking about electronegativity and the geometry of your Lewis structure. And a tip for you to remember is we can say that a molecule is polar if there are different elements on the outside of the central atom or the central atom has lone pairs. So we have examples here. So this is nitrogen trihydride. Okay, so looking here, we see that even though all of the elements on the outside are the same, we do have a lone pair on our central atom, so we can say this is a polar molecule. Looking at this structure here, we see that we have carbon as our central atom, and we don't have any lone pairs on it, but we do have different elements on the outside, right? So we have 3 hydrogens and 1 chlorine. And what we know about our electronegativity, we know chlorine has 7 valence electrons. It really wants to get that last one. So that one's going to be a lot more electronegative than the other elements in this structure. So we know that this is a polar substance. And if neither of these two things are present, then we can say our molecule is nonpolar. So looking at CO2, we see that we have no lone pairs in our central atom and that we have the same element on each side, right? We have oxygen and oxygen. So this is definitely going to be a nonpolar substance. So one more example, thinking about acetic acid versus carbon tetrachloride. So here, with our acetic acid, no matter whether you consider this one to be your central atom or this one to be your central atom, you can see that we have different elements bonded to it, right? So this carbon has 2 oxygens and another carbon. This one has 3 hydrogens and another carbon. So this is going to be a polar substance versus over here, our carbon tetrachloride. We see that we have no lone pairs in the middle, and we have the same element bonded to each side of it. It's also tetrahedral, so it's very symmetrical. So this is going to be a non-polar substance. So another thing that we want to think about is ionic compounds, right? So in the past few slides, we've been talking about covalent molecules. Well, what about our ionic compounds? So thinking about quarter 2, we talked about that ionic compounds are made up of positive cations and negative anions that are bonded to each other, right? So here we see we have our positively charged sodium atom and our negatively charged chlorine atom. Kind of similar if you think about the structure of water, right? We have that dipole moment where you have this partial negative charge on your oxygen because it's attracting those electrons. So because of the unequal sharing, we have a partial negative on oxygen and a partial positive on hydrogen. So when we think about an ionic solid that's dissolving in water, ionic compounds, these cations and anions are bonded to each other in a crystal lattice formation. So this is our crystal lattice formation here. In the middle, where you have the negative cation the negative anion and the positive cation. And all that lattice means is that you have an ordered repeating pattern. So when sodium chloride is exposed to a polar molecule like water, our positive sodium cations are attracted to the negative oxygen atoms that are in water, and our negative chloride anions are attracted to the slightly positive hydrogens. So these attractions break apart the crystal lattice, and the sodium chloride will dissolve. So the ions will still exist in our solution, but they've been separated by these water molecules. So an ionic solid will dissolve in water because of that. So we're going to do a little bit of practice here. So the first thing I want you to do is name whether it's polar, nonpolar, or ionic, and then tell me whether water will dissolve it or not. So I will give you a minute to think about each one before I then tell you what the answer is. So thinking about this one here, take a minute, look at it, and decide whether it's polar or nonpolar, and whether water will dissolve it. So this is going to be a polar substance. We see that our central atom, our phosphorus here, does have a lone pair. So yes, water will dissolve this substance because water is polar, and this is a polar molecule. Our next one, polar or nonpolar, and will water dissolve it? So think about it for a minute, and then I will let you know. So you should have said that this is a nonpolar substance, right? We have hydrogens that are all around here, and then our carbon, our central carbon here does not have any lone pairs. So if it's a nonpolar substance, then it will not dissolve in water, right? Nonpolar will not dissolve in a polar solvent like water. Our next one, so think about whether it's polar or nonpolar, and will water dissolve it? So this is another nonpolar substance. We see that our central carbon does not have any lone pairs, and it's bonded to the same element on each side. So this is nonpolar, and it will not dissolve in water. Next ones. So both of these are going to be either polar or nonpolar. So these are both going to be polar molecules. We see we have the dipole moments. That gives us a clue here, right? These dipole moments. But also how we would know is both of these have lone pairs on the central atom. So because they're polar, they both will end up dissolving in water. So this one's a little bit of a tricky one, but I'll give you a minute to think about it. Okay, so this is going to be a nonpolar substance. This is actually a triglyceride, so what fats are made up of. And the reason that it's going to be nonpolar is we see all of the symmetry that we have here, right? We see each of these is pretty much the same, right? We have oxygen bonded to a carbon with an oxygen, and all of these are just a bunch of other carbons. So because this is a very symmetric molecule, this is going to be nonpolar, meaning that water will not dissolve it. And then this is our last practice question here. Ionic, polar, or nonpolar? Will water dissolve it? So this is going to be ionic. This is going to be ionic, and water will dissolve it. So now I have some practice questions that I want you guys to try. So you're going to first tell me whether it's polar or nonpolar, and so that's an A. And then for B, you're going to explain why it's polar or nonpolar. Let's put some music on in the background while we're doing this.
Say yes to RAV4 Hybrid. Say yes to more power. More power. You're built for speed.
Okay, our timer has run out. If you end up needing more time, you can pause this and keep going. I'm going to move on and show you guys what the answers were to those practice questions. So take a minute to double check your answers, see where you might have gone wrong. And if you have any questions, I will be having office hours via Zoom later this week, so you can jump on that call and I can try to help go through anything that may be confusing you. So if you want to pause this and take a look, double check your answers, I am going to move on. So the last thing that I wanted to talk about is electrolytes versus non-electrolytes, and this has to do with our ions that we had just talked about, our ionic compounds. So a lot of times when you hear electrolytes, you're probably thinking of things like Gatorade, which people talk about to replenish your electrolytes, especially when you're playing sports. And so when we think of an electrolyte in chemistry, essentially what it is a solution that has an ionic substance dissolved in it, which conducts electricity. So if you think way back when we talked about ionic compounds, they are made up of metals and nonmetals, so they will conduct electricity. And so a strong electrolyte is one where there's going to be lots of ions that are dissolved in it, and a weak electrolyte is where there's few ions dissolved. So you don't have as many, but it still does conduct electricity. And then on the other flip side of that, you have a non-electrolyte. So non-electrolytes, this is going to be a solution that has a covalent substance dissolved in it, which cannot conduct electricity. So remember your covalent compounds, they're made up of nonmetals with other nonmetals, so they do not have the ability to conduct electricity. So what that's going to look like is, you see here, in this first solution here, in this first solution here, we have no ions. And so this light bulb is not lighting up because no electricity is being conducted. Moving on to this next one here, we have few ions, so there's not a lot, but we do see that our light bulb is lit just a little bit. So this is going to be a weak electrolyte solution. And then this solution over here that has many ions has a brightly lit light bulb because it's conducting a lot of electricity. So this would be a strong electrolyte right here. So just one more example, I want you to think, here we have ethanol, which has no conductivity, and over here we have KCl, which has a high conductivity. So I want you to characterize them as either an electrolyte or a non-electrolyte. So take a minute to do that on your own, and then we'll talk about it. Okay, so ethanol, because it's not conducting electricity, we would say that's a non-electrolyte, so this must be a covalent compound. And then our KCl, we should already know, based on our background knowledge, that KCl is an ionic compound, so it should be an electrolyte, and we see that it does have high conductivity. So this would be, because it says high, you could say that this is a strong electrolyte. So we'll do one more check for understanding here. Which of the following is a non-electrolyte? So remember, non-electrolyte means that it's not going to conduct electricity. So take a minute to think about it on your own, and then we'll go over the answer. So we can go through this using process of elimination. So KCl, we know that potassium is a metal, meaning that this has to be an ionic compound, which will be either a strong or weak electrolyte. You don't have to worry about strong or weak right now. We just know that A is an electrolyte, so we know A is not the answer. Moving on to B, we have magnesium and fluorine. We know that magnesium is also a metal, so this is going to be an electrolyte. Then we have over here copper and oxygen. We know that copper is one of our transition metals, so that is going to be an ionic compound, meaning that our correct answer here is D, right? Because we have carbon and hydrogen, which are both nonmetals. So this is a covalent compound, also known as a non-electrolyte, which will not conduct electricity. So here you have 3 independent practice questions, just to test your knowledge of electrolytes versus non-electrolytes. So I'll give you 5 minutes to do that, and then we will come back and discuss together. Okay, let's start wrapping that up. So we'll go over the answers quickly. So number one was asking which of the following is a non-electrolyte, and the answer you should have gotten was B. So that's the only one there that's made up of all nonmetals, meaning it's a covalent molecule. Number two, same sort of question, which one is the non-electrolyte? You should have gotten F. Again, only one made up of covalent elements. And then the final one, which substance will be an electrolyte when dissolved in pure water? This is the opposite, right? So now we're looking for an ionic compound, and the only one that's made up of a metal and a nonmetal is going to be A, your CaCl2. So the final thing that you can do to practice this polar and nonpolar is go to this link, and it'll pull up quizzes, which is kind of a little bit like Kahoot, but you can do this individually. And you'll just click on this solo practice. You'll click practice, and it'll give you questions about whether it's polar or nonpolar. So go through, give that a shot, practice it. And then if you have any questions, again, I will be having tutoring later on this week. So you can come on the Zoom call, and I can go over anything you may still have questions about. Thank you for tuning in to this presentation today about polarity. Miss you guys.